When you work on a data analytics problem in industry, the problem is likely very complex, requiring a combination of many techniques and the use of many tools. This video will give you an overview of the kinds of techniques you should learn about. In later videos, we'll go into more depth about some of them. The ability to decompose a complex problem into simpler ones is one extremely important skill that all data scientists should have. In addition, a data scientist should also be able to identify parts of the problem that already have known solutions so that they can use and apply existing tools to solve those parts. This will allow us to focus our energy on the harder parts of the problem. The good news is that while there may be a huge number of complex problems to solve, there's only a small number of categories of analytics tasks. What we'll do next is to go through 8 of them based on the book Data Science for Business. An important point is that these tasks are not mutually exclusive, meaning some tasks can share some underlying principles or algorithmic techniques. In fact, towards the end of this course, you will see that some of these principles and techniques form the foundation of many higher-level tools. Let's look at classification first. Classification is the most common analytics task. In one sentence, what classification does is to predict which class an entity belongs to, as shown in the green text on your screen. An alternative name for class is label, so we can also say that classification is to figure out the label of an item. You can easily come up with examples of classification problems, from classifying emails into spam or not spam, classifying the sentiment of tweets, labeling medical images to detect cancer, and so on. A second closely related task is regression. The one-sentence summary is to predict the numerical value of something that you care about, such as predicting temperatures, stock prices, credit scores, game scores, wine scores, and so on. The reason that regression is closely related to classification is that you can always convert the results of regression, which is a range of values, into a few classes by thresholding the values. For example, you can decide that any temperatures below 70 is cool and any above is warm, and you now have a binary 2-class classification problem. The inverse going from classification to regression is not always possible, however, and for that reason, some people say regression problems are harder to solve. The third task is similarity matching. This means you want to find other things similar to what you are interested in, as in finding similar gene sequences, similar patients, or finding like-minded people to date. The need to find similar things, in fact, underpin other category of tasks. For example, in classification, suppose you know that the label of an item X, and if you are able to locate the other similar items of X, you can assign the label of X to those unknown but similar items. Our fourth task category, clustering, is based on similarity matching too. Clustering means grouping things based on their similarity. Clustering is a fancy way to say group. For most clustering algorithms, the user of the algorithm would need to provide a number of groups to find, because for the same data set, it can be correct to use different numbers of clusters, depending on the user's tasks. For example, we can say there are 10 small groups, or we can merge them into, say, 2 bigger groups. We can find examples of clustering in topic discovery for documents, determining land cover, and user segmentation in advertising. In this video, we highlighted the importance of being able to break complex problems into simpler ones so that we can focus our energy into the harder parts of the problem. Then we went through 4 categories of analytics tasks: classification, regression, similarity matching, and clustering.